So here we're going to talk about 2.3, flow and followers. So here are verbal descriptions of two situations. Situation one, a person has 80 followers on social media. The number of followers triples each year. How many followers would they have after 4 years? So here, year zero, they have 80 followers. Year one, 240 because it tripled, 720, and so on. So, situation two, a shark tank contains 80 gallons of water and it gets filled at a rate of 3 gallons per minute. How many gallons would be in there after 4 minutes? So we have 80 plus 83, 86, 89, and 92. So down here, if we had to figure out, well, which one matches situation A, now, situation A is exponential because we're constantly multiplying by 3. We're tripling. So here, letter A matches situation A. 80 times 3 times 3 times 3 times 3. Letter B also matches that. Our table does. So we have this one, and if you notice, if we did 3 times 3 times 3 times 3, that ends up being 81. So letter F also matches situation A. If I were to write a situation A, we would have y equals, our initial value of followers was 80, and then times, you can either use a dot or parentheses. Our growth factor would be 3 to the, and I'm going to put y to represent years. So I'm going to switch this from being y and call it n, our number of followers. So I'm here to define my variable there. That's number of followers. This y stands for the year. This 80 is an initial value. And this 3 is our growth factor. Now our other situation, situation B, is linear. Now if you notice here, we have 80 plus 3 plus 3 plus 3. That is C. Or 80 plus 4 times 3, letter D fits in there. And this table of adding 3 also fits, which is letter E. If I were to write an equation between y and x, y would equal, again, our initial value would be 80, plus on here, our slope, or our rate of change, as x increases by 1, y increases by 3. So I would add 3 times the x value. Again, in this linear equation, this is our y-intercept, or again, our initial value, we can call it. And this would be our rate of change, or our slope.